Okay, so here we've got another proportions problem, proportions and ratios problem. And it's a good one because it has, you can see sort of similar applications in a lot of different fields. So it says Sunshine Preschool has a staffing policy that requires a certain ratio of resources. In this case, for every 60 children, there are 3 preschool teachers, and for every 24 children, there are 2 aides. And that actually, that kind of setup where you're, just, you have a policy, like how many adults in this case to children, or it could be how many nurses or to patients, or in business, it could be how many salespeople for the companies that they're supposed to serve. So that kind of policy where you're really kind of setting a ratio that as a policy that you want to kind of maintain, it's really common in a lot of different fields. So this is a preschool. So I'm going to, first of all, use that Buck approach for word problems where you box the question. So let's see if the question is happening here at the end. If the school has 100 children, how many preschool teachers should it have? So that's actually one question. Okay, and then also how many aides should it have? All right, so there are 2 questions there. Then we would be asking in terms of the Buck to underline any key information. I'm going to do that in red. So key information is the sort of, the policy expressed as a ratio. So if you have 60 children, you're supposed to have 3 preschool teachers. If you have, for every 24 children, there would be 2 aides. All right. So that's really important. The other important thing, too, for this problem is the actual situation where the school has 100 children. That's important, too. Okay. So I'll kind of highlight that in red. The C in the Buck approach is to make note of any kind of important or unfamiliar vocabulary. It probably would be helpful to realize that a teacher in a preschool setting is a little bit different than an aide. Okay? A teacher, usually has more training than an aide. They usually get paid a little bit more, and usually, most of the time, you might have, a few more aides around than you would have teachers, frankly, because they're cheaper. So that's kind of an important thing. And then K it would stand in the Buck approach, means knock out any unnecessary information. It's probably not that necessary that we know that it's Sunshine Preschool. I think everything else is kind of important in this case. All right. So let's start with the first problem. That's about how many teachers should the preschool have. So here, we are interested in, first of all, the ratio of children to teachers. Okay, and we're told that the policy is that if there's for every 60 children, there should be 3 preschool teachers. Okay, and then that ratio should be equal. That ratio should be equal to the situation where we have 100 children. So if we have 100 children, the question is then, how many teachers should we have? Okay, and so one thing just I want to point out here that's really important, I've always found this really helpful, is we've got a lot of numbers here. We've got 60 and 3, and we've got 100, and we also have 24 and 2, but that has something to do with aides, so we'll set that aside for a second. One way to kind of check that you've set up this proportion correctly before you start doing any kind of calculations is I do like to say, I like to set up like a little check here with words. And that is that I've just decided, it doesn't really matter actually, but I've decided when I set this up that I'm going to put the numbers pertaining to children on the top and the numbers pertaining to teachers on the bottom. Now that way it makes sense to me. It would be like children per teacher, all right? But children on the top, teachers on the bottom. And I actually do like to kind of write it out like I have here. And that way I can check and see, well, does 60 in the problem, is 60 pertaining to children? Yeah, it is. Okay. Is the 3 about how many teachers there would be, in the ratio? And it is. Okay. Same thing over here. Is 100, is that about children? It should be because it's at the top of the ratio. It's at the top of the numerator, the fraction. And if you look back at the problem, it is about 100 children. Okay. So that means that I've really kind of set this up. And if you remember from your, basic work on solving proportions, what we would need to do to get rid of this sort of fraction situation here is to calculate cross products. Okay. So you'd get 60t is equal to 300. Some other approaches here. You might want to reduce that fraction 60 over 3 first, but you could do it just this way. You don't have to reduce. We'll worry about maybe reducing later if needed. And 60 times t equals 300. If you want to just get 1t all by itself, you're dividing both sides by 60. Okay, and if you do that, you get t, the number of teachers, equals 5. So in that situation where there's a school of 100 kids, you're going to need 5 teachers according to the policy. So let's look then at the next problem, which has to do with how many aides you should have. So here we have children to aides. It's going to be different than children to teachers because, like I said, aides come a little cheaper than teachers. So schools usually have a little different ratio set up for that. And the original problem said that you had every 24 kids, you're supposed to have 2 aides. But in this school that we're talking about, there's not 24 kids, there's 100 kids. And you want to find out how many aides there should be in that case. So I'm going to do this a little differently, and I'm going to say, look, 24 divided by 2, that kind of reduces to another fraction. I'm going to say 12 over 1. Right? 24 divided by 2 is the same thing as 12 over 1 if you reduce it. Looks a little weird, I know, but it's not untrue. And then, okay, if I cross multiply here, I'm using A for aides just to remind me what I'm solving for here. 12A is equal to 100. Right? I want to get just one A by itself, so you have to divide 12A by 12, and that'll just give you A. So A, the number aides, is 8.5 aides. Now that's kind of a little bit of a funny situation because you can't really have half an aide. I mean, maybe you could have an aide that, a person who's half-time, perhaps. But maybe to play it safe, I guess, and make sure, if you're the hiring manager, that you're following the policy, maybe to make sure you'd sort of round up in that case. Play it safe and hire 9 aides, unless you could get one, maybe for halftime. Okay. So I do want to emphasize, actually, when you're solving proportions, I always find it really helpful to write out in words what those ratios mean, and then you can double check to make sure you've got the numbers in the right place, right? So did 24 really apply to children here? Okay, if you check back at the word problem, it did, all right? And the 2, was that really pertaining to AIDS? Sure, okay. Likewise, we know that our unknown here, which we're letting be A, right, that is about how many aides would we need in that situation of 100 children. So if you're having a little trouble with solving the proportion problems, that's a really good tip.